If you recall, we've been talking about graphs and sines and cosines, and we've been wanting to, the basic problem is two directions. If I give you an equation like we have here, only with like actual numbers running around, if we get an equation, we should be able to produce the graph. Or if we get a graph, we should be able to produce an equation. So it's a two-way street. So we want to be able to given a graph, write the equation. And if we're looking at an equation, we should be able to produce a graph. So we want this to go, we want to be able to go both ways on this problem. If I give you an equation, write the graph, specifically the information about the graph. Or if we're looking at a graph, be able to write the equation. The things that we want to find are these four things, the four changes that we have. We have addition and subtraction. We have, addition and multiplication, and we have either before the trig function or after the trig function. That's how we categorize things. We have addition and multiplication as operations, and these operations will take place before or after the trig function. The addition operations we have are C and D. And when we add, like so, C and D, they represent shifts, keeping the same shape, just moving it up and down or left and right. So this represents a shift. Multiplication is covered in A and B. And multiplication will produce some kind of stretch. So that'll be a stretch or a compression, horizontally or vertically. So multiplication produces a stretch, addition produces a shift. The before and after part tells us whether something is going to be horizontal or vertical. So the two that go before the trig function are B and C. Operations that go before the trig function are going to be changes that are horizontal. The changes that come after the trig function, which are A and D, are going to be vertical changes. In the category of vertical changes, we're going to have what the amplitude is. And the other vertical change is where the middle is. In the category of horizontal changes, we'll make adjustments to the period. And adjustments to the start. Let's say it's the 0 of the start. What we're counting as the 0 of the start. The start has two parts, depending on the trig function and the sign of the amplitude. Positive cosine starts at the top, negative cosine starts at the bottom. I think I listed all these in purple last time. We start positive cosine at the top. We start a negative cosine at the bottom. Positive sine, we start at the middle going up. Negative sine at the middle going down. But here are all the things that we'll have to notice. So the things that we're going to want to figure out are the amplitude, where the middle is, that's the vertical stuff. Once we have the amplitude in the middle, that'll tell us what the top and where the top and the bottom are going to be. We're also going to want to calculate the period and then figure out where we're going to start, what the zero value of the start is and what the point of the start is. Remember that the sequence of starting of the points is top, the middle going down, then the bottom, and then the middle going up. And then this just repeats. Forever and ever, no coda. So we got a checklist of things that we need to find when we're looking at an equation. What's the amplitude? Where's the middle? What's the period? Where are we going to start? What are we going to put at the, where are we going to put the zero at the start? And which of the 4 points are we going to start at? We want to think about how these changes are categorized by the operation, addition or multiplication, and whether or not that operation comes before or after the trig function. Let's look at an example. So here, maximal example. I've changed all 4 numbers from the default. The multiplication defaults are 1, the addition defaults are 0. Because those are the multiplicative and additive identities, respectively. So first, we just want to identify what A, B, C, and D are and what those numbers tell us about this function. First, we'll notice that A is -5. So this -5, we can see that A is -5. A tells us 2 things: the amplitude and which point we start at, part of the point that we start at. So the amplitude is just the absolute value of this. So the amplitude is the absolute value of 5, or just of -5 or just 5. And we have a negative cosine, so we're going to start our graph at the bottom. We've got negative cosine. So we're going to start our graph at the bottom. The next number that we come across, or actually maybe the next number that we want to look at, since if we want to look at our vertical stuff, now that we have the amplitude and that we're starting off at the bottom, we can go over to D, and we can see that D is equal to -2, so the middle is at -2. I can combine the middle and the amplitude to figure out where the top and the bottom are going to be. The top will be the middle plus the amplitude, the bottom will be the middle minus the amplitude. So the top is going to be at 3 and the bottom will be at -7. The middle is at -2 and I have an amplitude of 5. 5 up and 5 down. I've got all of my vertical information sorted out. Next up, we can go with our horizontal information. In the multiply spots, x is being multiplied by pi over 6. So we see that b is equal to pi over 6. This number modifies the period. This number modifies the period, and the period is going to be 2 pi divided by b. So we'll take 2 pi and divide by pi over 6. So we'll take 2 pi and multiply by 6 over pi. Gives us a period of 12. This is why I picked such a weird value for b, so I could get a nice period of 12. Question? Period is the distance between the top point and the next top point, or the bottom point and the next bottom point. It's the length of one cycle. It's the distance from the top to the top, the mid going down to the mid going down, the bottom to the bottom, or the mid going up to the mid going up, between any two corresponding points. The length of one cycle. The last thing we could look at is what the value of c is. And it looks like we have x minus 1. So c is equal to 1. C is the number after we say x minus, and the number after, and we say x minus 1. So c is equal to just 1. So instead of starting at 0, we're going to start at 1. Instead of starting at 0, we're going to start at 1. And now we have all the pieces that we need. Five things that we need to know. The amplitude, the middle, 7 things. The amplitude, the middle, which we use to get the top and the bottom. The period, and then 2 parts at the start, where what we count as 0 and which point we start at. So here is a generic sinusoid. The things that we can identify are where the middle is. The middle will tell us, and the amplitude will tell us where the top is. And the bottom. So here are the things that we know. We calculated the middle to be at -2. So this line is happening at -2. The top is happening at 3. And the bottom is at -7, because the amplitude is the distance from the middle to the top. And the middle to the bottom. I want to think of my starting point. Since we have a negative cosine, I want to put the starting point at the bottom. So I'm going to pick one of the bottom points and say this happens when x is equal to 1. Instead of starting at 0, we start at 1. That's where we hit the bottom. Next is we know where the period is 12. So that's the distance from the bottom to the bottom. So here's where the next bottom point is. Also down to this bottom point back here, that will also be a distance of 12. That is the length of one period or cycle, one cycle. Now we just have to figure out the coordinates of these points. So if this down here is at 1, 12 units later, this must happen at 13. 12 units before that, this the previous bottom must happen at -11. And now we can identify all these points. So since one cycle is 12 units, that means each quadrant is 12 over 4. So a quarter of a period is just 3. So each quadrant so each of these points is going to be 3 units apart. So 1 plus 3 is 4. 4 plus 3 happens at 7. 7 plus 3 happens at 10. 10 plus 3 happens at 13. If I go backwards, 1 minus 3 is at -2. -2 minus 3, this happens at -5. Minus 3 is -8. Minus 3 again is -11. Remember, each cycle we think of as once around the circle, and that circle is divided in 4 quadrants. And that's where our sequence of points happens. Top, middle going down, bottom, middle going up. Repeat. Now we can go through and label all these points. This point down here is at 1, -7. This point is at 4, -2. This point up at the top is at 7, 3, and so on. 10, -2. And then this bottom point is 13, -7. Questions? Yes. So which one? The 12? So the 12 is the length of one period. So we get the coefficient of x, that's b, and the period is 2 pi divided by b. So 2 pi divided by pi over 6. Pi over 6 gets flipped over. If the pi's cancel, we get 2 times 6 or 12. So that's the length of one cycle. So if we have the bottom point here at 1, then 12 later, the next bottom point will be at 13. Now we would want to check this. We can check this by plugging our equation into a graphing calculator. Well, it looks like a sinusoid. Cosine was orange last week, wasn't it? I think so. Now the middle is hard to find. We can see that the bottom point here at 1, -7. The next bottom here is at 13, -7, like we predicted. The tops all happen at 3, and they are 12 units apart. It's hard to find where the middles are. So if we graph just y equals -2, that'll show us where the middle is. I made the middle green. And there's the two middles that we had, 4 and 10. And we can see our top and bottom. We can see that between any two corresponding points, we go from middle going down to middle going down, the difference in those x coordinates is going to be 12 because the length of one cycle is 12. So from -14 to -2, from -2 to +10, from +10 to 22, those are 12 units apart. The length of the period is 12, so the distance from the bottom at 1 to the next bottom is 13. The previous bottom happens at -11. Any questions? Comments? Slide remark. Okay. Identify 5 things. Now, we could have just graphed this on the graphic calculator and looked up all these things. But that's coming from the standpoint of finding these things and producing the graph is the point. It's about reading the graph. Because we also want to do this backwards. Everybody okay? Everybody looks so very sad. Because it's just too easy. Why don't you challenge that? It almost all fits. Take a few minutes, find out the 5 things that we need to find out for this function. So read the 4 numbers, decide on the 5 things that we need to know. Amplitude, or 7 things, I guess. Amplitude, middle, which leads to the top and the bottom. Figure out where you're going to start based on the sign of the amplitude, or sign of A and the trig function. Then figure out the period and the horizontal shift, or where the new 0 is. Let's take a few minutes and analyze this function. So here are the details of our new function. We want to identify A, B, C, and D and what they need and where the start is for our function. Then we can just fill in the details, and that will allow us to find any of the significant points on our graph. So first off, we identify the coefficient. A is -4. That tells us a couple of things. First of all, the amplitude is 4. And since it's a negative sign, we're going to start at the middle going down. That's what we're going to think of that new 0. That's the new 0. We'll start at the middle going down because negative sign. Next number we run across is B, which is pi over 10. The period is 2 pi divided by B. So 2 pi divided by pi over 10 is going to be 20. The pi's cancel out. 2 divided by 1 over 10. We flip the 1 over 10 to 10 over 1 and multiply. So if you look at the pi over 10, if I give you that style of B, is multiply the denominator by 2. That will be the period. The reason that's always going to be an even number is that I know that I want to divide the period by 4 for the 4 quadrants. So if I pick an even number, I can divide it by 4 because the 2 also shows up from the regular period of 2 pi. The next number we run across is the horizontal adding and subtracting, and it says x plus 2. When we want to identify what c is, the base model says x minus c. Whatever we say after x minus, that's what c is. So when we read x plus 2, we have to know that that came from x minus -2. So that tells us that c is -2. Just like in the previous one, whatever comes after x minus, that's what c is. And it said x minus 1, so c is 1. In this case, since it says x plus 2, we read that as x minus -2. So C is -2. We'll move the start from 0 to -2. And finally, D is 3, +3, and that says the middle is going to be at 3. Since the amplitude is 4, the top is going to be 3 + 4 or 7, and the bottom is 3 - 4, -1. So now we can fill in all the details on our generic graph. I know this looks like the same graph. I assure you it is radically different because look at how different the numbers are. If like, oh, dude, that looks like the same sinusoid, that's because the sinusoids all kind of look the same. And we're changing it by our labels rather than by our size. So the middle is at 3, and the amplitude is at 4. So 4 up from the middle, and 4 down from the middle. Is going to put a top of 7 and a bottom of -1. Now we have sorted out all of our all of our vertical stuff. The next thing to sort out is our horizontal stuff. I know we're going to start at the middle going down, so I'm going to pick one of these points where the middle is going down. I'm going to pick this one, because this point is at a middle going down. And I'm going to say that this happens at -2. I picked a middle going down because my equation says negative sign. So that says do the middle going down. And then whatever C is, that's what the new 0 of the middle is. The fourth thing to sort out is the period. The period is 20. So that's the distance from this middle going down to the next time we see a middle going down. And if I run this backwards to the previous middle going down, those are going to be 20. That's the length of one cycle. This will help us figure out where all these significant points are. -2 plus 20 is going to be 18. -2 minus 20 is going to be -22. And we want to figure out the points in the middle. So we need to know what 1/4 of the period is. So 20 over 4, or 5. So 1/4 of the period is equal to 5. So now I can tell where all these points are. So -2 plus 5 is 3, plus 5 is 8, plus 5 is 13, plus 5 is 18. Since I landed after 4 quarter periods, I landed on the 18, which just as we expected. So we know that things are working. If I go backwards, this top point happens at -2 minus 5, -7. -7 minus 5 is -12. -12 minus 5 is -17. -17 minus 5 is -22. Now I have the coordinates of 2 full cycles. If I wanted more than 2 full cycles, if I needed more points, 18 plus 5 is going to be 23. And we can go forever in either direction. So those are the eight things that we need to know. The amplitude, the middle, leads to the top and the bottom. The start, location, and which point it is. What the period is, and what a quarter of the period is. 8 things. Nobody expects the Spanish Inquisition. Questions? Let's take a pause and then come back and do this problem backwards.